All right, guys, so what we're looking at here is 2012 particle motion example number 6. And to be honest, this question should be done without a calculator, but I dislike it without a calculator so much that of all of them, I don't care that you did use a calculator on this problem, even though you were not supposed to, okay? So we've got a particle moving along the x-axis. The velocity is given, so we have a velocity function. We also have a time interval. We're going from 0 to 12 this time. And we have an initial position of x equals -2 at time equals 0. So those are the things that we're given in this problem. Is we always want to identify them to make sure that we understand what we've got. And again, much like the other ones that we've looked at thus far, we can see that there are an awful lot of things that are very similar. So letter A wants to know, when is the particle moving to the left? Now what that's asking is, on the interval from 0 to 12, where is this graph below the x-axis? So you graph it and you find out that it dips below the x-axis at time equals 3 and it goes back above the x-axis at time equals 9. So we would say that from 3 to 9, that is when this particle is moving to the left. Again, just looking to see where that graph is below the x-axis, and it doesn't ask for any sort of justification, so we're good. Letter B, and this is very typical of problems when you do not have a calculator. It says, write but do not evaluate an integral expression that gives the total distance traveled from time equals 0 to time equals 6. Well, this is basically just, okay, what is my actual answer here? That is just the absolute value of the velocity, dt. And you can actually write it just like that. If you want to put the cosine in there as well, that's totally fine. But because I don't have to type this into my calculator, that's what it means for write but do not evaluate. This answer is my final answer for letter B. On letter C, it says find the acceleration of the particle at time t. Okay, so it wants us to take the derivative. So I need my derivative function. I take the derivative of cosine, which is negative sine of pi over 6 times t, and then I multiply that by the derivative of pi sixth, which is just pi over 6. So that is my acceleration. Then I want to know if the speed is increasing, decreasing, or neither at that time. What that means is I have to take 4 and plug that into both the acceleration and into the velocity function. My acceleration function here is, I get a negative number, and the same is true for my velocity function. Since both of those are negative, that means that my speed is going to be increasing because those two things are working together. Okay? And then letter D wants us to find the position, which means we take my initial position and then I add to the integral from when it gives me the initial position, which is time equals 0, to when the position of the particle, that's time equals 4, of my velocity function. Now again, without a calculator, this last step is actually pretty difficult. But with a calculator, and I only actually have the exact answer here, you get the -2 plus, when all is said and done, you get 3 square roots of 3 over pi for everything else, which again, I'm not expecting you guys to be able to do that, but if you type that into your calculator, it gives you a decimal answer, which is the correct answer for letter D. I'm much more interested in making sure that we can set the problem up correctly to do all of these particle motion problems. But everything here, like I said, I feel like this was a fairly straightforward problem, not asking anything super weird. It would have taken a little bit more time without a calculator, and quite honestly, some of the trig was probably beyond what we are able to do. That's why I wanted to focus on doing this with a calculator so that we have the ideas down. If you have any questions about this one or any other videos that I've made, please let me know.